Bipolar junction transistor (BJT) is one of the most fundamental and widely used electronic components in electrical and electronic engineering. A natural question arises: why are BJTs still taught and used even in the era of MOSFETs? And the answer lies in their clear physical behavior, strong current amplification capability, and predictable performance in analog circuits. A BJT is a current-controlled semiconductor device composed of three regions: emitter, base, and there are two main types of BJTs, NPN and PNP. In an NPN transistor, electrons are the majority carriers, while in a PNP transistor, holes play the dominant role. The emitter is heavily doped to supply charge carriers, the base is thin and lightly doped to control the current, and the collector is moderately doped to collect carriers. This internal structure allows a small base current to control a much larger collector current, which is the key principle of amplification. The basic operation of a BJT can be understood through its operating regions: cutoff region, active region, and saturation region. In the active region, the base emitter junction is forward biased and the base collector junction is reverse biased. This is the normal region for amplification. The fundamental current relationship is where IC equals collector current, IB equals base current, beta equals current gain of the transistor, IE equals IC plus IB. The base emitter voltage, VBE, for a silicon BJT is typically about 0.7 V. This voltage is essential for turning the transistor on. From a more advanced and scientific perspective, the collector current is described by an exponential equation. IC equals is times E caret VBE VT, where is equals reverse saturation current. VT equals thermal voltage, approximately 26 millivolts at room temperature. This equation shows that the BJT is a nonlinear device. However, engineers often linearize its operation using biasing techniques to design stable amplifiers. In switching applications, in the cutoff region, IB approximately equals 0 right pointing arrow, IC approximately equals O transistor OFF. In the saturation region, VCE approximately equals 0.2 V right pointing arrow transistor fully on. In saturation, increasing the base current, which is an important design consideration. BJTs are widely used in amplifier circuits such as common emitter, common base, and common collector configurations. Among these, the common emitter amplifier is the most popular due to its high voltage and current gain. Advantages of BJTs include high current gain, good linearity in analog circuits, simple and well understood theory. However, BJTs also have some disadvantages: higher power consumption compared to MOSFETs, sensitivity to temperature changes, requirement of continuous base current. In industrial and practical applications, BJTs are used in audio amplifiers, signal processing circuits, voltage regulators, power supplies, and educational laboratories. Understanding BJTs provides a strong foundation for learning advanced topics such as analog circuit design, feedback systems, and semiconductor physics. In conclusion, bipolar junction transistors remain an essential topic for both general learners and professional engineers. Their simple structure, powerful amplification capability, and rich theoretical background make them a cornerstone of electronics education and practical circuit design.